Well, Joe, thank you really very much for agreeing to do this. We're going to talk a lot about some of the things that you've been doing, including your most recent book, Dancing with Roomba, which I want to read. But I want you to know that mobile robots, I think from like 1998 was like the go-to book for me getting into this space. So thank you for writing that book and sharing.
It was a pleasure. Thanks for reading it.
Oh, it was awesome. It's fantastic. And I still have it on my bookshelf. It's like a reference
Cool.
for how to build robots. But also, we're going to talk a lot about this too. You are the co-inventor or one of the first employees, I believe, at iRobot, and
Yep.
one of the guys behind the Roomba, former senior roboticist there. And then we'll talk a little bit about Harvest Automation, what you've done there, and Tertill Corporation, and all the things that you've done. Just amazing stuff in the robotics space, consumer robotics, no less, which is really difficult.
Tell me about it.
Yeah. Well, actually, so on that topic, I think, was it you who said that robots should have a purpose, not a narrative? Or is that
I would agree with that sentiment. I don't know whether that's a quote from me or not, but
okay?
yeah.
Well, it's interesting because it's like kind of saying why robots shouldn't exist, to some extent. And so, like, what's a robot today that you think, exists mostly for narrative or for,
Oh, there have been so many over the course of my career. I'm always very suspicious of robots. When somebody announces a new robot, I think, "Are you kidding me?" And when I endeavored to build a robot to solve some task, the first thing that I always try to do is to figure out if there's a way not to build a robot. Because if there is, right, if there is some simpler, cheaper, less unfamiliar way of solving the problem with something that way is going to win, right? So don't bother building a robot. So I don't know. I don't want to come down too hard on humanoid robots, but they harken back to the early part of my career where everybody seemed to want to build a general purpose robot. And people sunk lots and lots of money and lots of time and effort in trying to build a general purpose robot. And I don't think any of them ever succeeded. I mean, really, they survived in the marketplace for a short time, but none of them became what Roomba became. So any robot that doesn't address a specific task, I'm suspicious of.
interesting. So now there's humanoid robots, which have some general purpose, presumably general purpose capability, and that's why they build them. And then I guess are there other form factors besides humanoid that you've seen that have been kind of general purpose oriented?
Well, in the early days, everybody wanted to build a platform robot. And usually what that meant was just something with wheels that rolled around. And then you would deliver that to the customer and your customer would figure out what to do with it. And that always proved to be a bad business plan.
So it didn't really do anything; it just rolled around.
They always claimed it can do everything, whatever you program it to do, which
Right.
really meant that it can do nothing at all. When you take it out of the box, it can't do anything. And it's left to the customer to figure out how to make it do something useful. And I mean, we're the roboticists, right? We're supposed to figure that out. That's what you pay roboticists for. And to push that off on the customer, just it seemed like the wrong thing. But it admits that, solving any task with a robot is really, really hard. So you've got to be sure that really the robot is the best way to accomplish that task. Otherwise, it's going nowhere.
Right, right. Well, sort of in that spirit, I've been in the autonomous vehicle space for a while. Like, what are your candid, thoughts on this? Because in some applications, I will just say I've seen, you know, with buses, for example, I think these, a lot of these transit groups will still have people in the driver's seat, or at least on the bus to help others get on and off and deal with medical conditions or what have you. You wouldn't want to just have like a bus full of people kind of
Right.
by themselves. Although the driving test may be true. But what are your thoughts about not just maybe the autonomous vehicle space? Is that like an example, or are there other sort of big ticket examples where this shouldn't be happening?
Well, I wouldn't say that autonomous vehicles shouldn't be happening. That they're cool in a lot of ways. Um, I have never wanted to work on them myself. And part of the reason for that is because they have the ability to do a whole lot of damage, and they don't have all the subtleties of, human perception and understanding to avoid doing that damage. So what that says to me is that the very best place for an autonomous vehicle is where it's constrained in some way. Rather than working out on the highways where it has to interpret everything. That's well, AI has gotten a lot better. Maybe that's possible now, but for the great majority of my career, that was not possible. And people were just kind of fooling themselves when they thought that they could to build an autonomous vehicle that would work as well as a person in every situation. And it also seems to me that um, engineers succeed in part by putting boxes around things. You say that this device that I'm building, it's supposed to operate in this sort of circumstances and not this other set. So if you try to, put you want to clean your engine block in your washing machine, that's not going to work, right? That failed. It's a washing machine. It doesn't wash anything. You have to understand it. So there's a box that you put around how this machine is supposed to work, and the customers have to understand that. But when you're driving a car just down any highway anywhere, there's no box that you can put around it. It has to have the same facilities that a human being would have, and that seems really difficult.
Yeah, yeah. Unless you constrain it, like you say, in sort of its operational environment, perhaps, right?
Yep.
And in limited conditions. Interesting, interesting. You know, just thinking of going back to humanoid robots, where we kind of let off this conversation about general purpose robotics. Why shouldn't humanoid robots exist? Or maybe that's a little harsh, but why? But what do you think is their sort of problem with gaining traction in the human world?
So I certainly wouldn't say that they shouldn't exist, or that
Right.
nobody should be working on them, or that we shouldn't be doing research on them. That's great. Absolutely, I'm always in favor of research. Uh, but the problem that robots have had over most of my career is that they constantly made promises that they couldn't keep. You can see in the early days, you'd see a robot doing this clever thing, and you think, well, because it can do A, then clearly it must be able to do B. And really, it could only do A. And all of the rest of the stuff that you imagined, that was in your head, not what the robot could actually do. So humanoids very definitely make a promise. They look like us. They kind of act like us. You expect that they have the same sensibilities and capabilities as us, and so far they don't. Um, in particular, in dexterity, we have all kinds of sensors, not just pressure sensors, but other sorts of sensors that help us to manipulate things. And robots basically just have the pressure sensor. And you try to train your humanoid robot by having it watch a person doing some task. This is one of the ways of doing it. But we don't just use our eyes when we're figuring out how to manipulate something. We use all those other sensors that just are not available to the robot. So it makes it hard for the robot to succeed. And I'm also just very suspicious of general purpose anything, because it's usually so much easier to build something that does one thing well than that does everything well. Um,
Sure, sure. Well, I guess so, but with humanoid robots, I guess, do you see any sort of, it seems to me, I guess, of course, it depends on the size and how it's constructed, but if they're to be around in a home, I mean, they're babies and cats and dogs and fragile furniture and what have you. It
yes.
seems like, you lose power, these things could just tip over. So,
Yeah, that is one of the issues. It's not too hard to build some device that works most of the time, and most of the time it's great. But in some sense, it's fundamentally unreliable because, like you say, the robot is walking along through your living room, and suddenly there's a glitch, or the battery loses contact, or something, and it topples over onto Fido. And there's there's kind of no safe way around that except to
yeah.
not build this walking thing that is capable of falling over and crushing something.
Right, right. I mean, we as human beings, fall, right? Obviously, so and
Yes.
trip over things and what have you, and but yeah, I can certainly. And then these bigger, larger metal robots walking around, um, loved, cherished things and valuable things seems, yeah, fraught with peril. Um, so on the general purpose side, from an economic standpoint, um, when someone buys a robot, it's going to cost a certain amount of money. I don't know, of course,
Yeah.
it could be, if it's a toy, it might be $100 or under. If it's something more advanced, 1,000 or what have you, somewhere in that sort of spectrum, maybe on the home side. And and if you try to sort of say, well, you're going to have specialized robots for all these different functions, does that become just inordinately expensive? Because now you would need, how many robots would you need to accomplish all the things that they're being, promised to solve, and how much would that cost?
Well, um, you can make the same sort of argument with like, why should I buy a car and an airplane, right? Why shouldn't I buy a flying car, right? Why don't I just combine all of the features that I want into one thing rather than having to buy two different things? And the reason that you don't do it, and the reason that there aren't really any what we always classically thought of flying cars, is because when you do that, you get a bad car and a bad airplane. The compromises that you have to make to do one thing well are sort of the opposite of what you want to do the other thing well. Um, and it's hard for people to imagine that, perhaps it's hard that there's some other form that would do a task better than us. But it seems that we were evolved to do a certain task, and that was basically to survive on the ancient plains of Africa and climb trees. So if that is the task, then yes, this is the right form. This is the way to do it. But for just about anything else that you can think of, if you started from scratch and said, what's the most economical way to accomplish this particular task, you would not come up with this form. You would do something different. And I don't know how the economics ultimately will play out. It may, if the general purpose machine gets to be cheap enough, then it will win. I acknowledge that. I just don't think that we're there yet, or that we will be there in the next, in years.
Yeah, yeah. Well, it's interesting, the human analogy you make too, about how our, bodies have evolved, because it's true. We've we're an adaptive species. We've somehow learned to drive, vehicles, cars, 55, 65, of course, faster miles per hour.
Yep.
And of course, we were not designed, our sensors and actuators, so to speak, were not designed to go that fast.
Right.
And that's why it's, dangerous for us in some regards, and there's so many
Yeah.
accidents, but we're doing pretty well. But, that's where
Yeah.
the automation angle comes in, right? Um and um and so, but we have been, like, this form has been incredibly multi-purpose for us,
Oh, I
right?
agree. Absolutely.
We built so many things, and so, yeah, and maybe that's, you think that's what people are thinking is going to, that's why they're just trying to, in this bio-inspired fashion, build the humanoid robots, because they're gonna somehow make it do the same thing?
Well, a cogent argument in favor of building humanoid robots is that we have built a world optimized for us, right? All the tools, they fit into our hand, and they're designed for us to use. So obviously, we should build a robot that can use all of those tools. Um, but if you succeed, then you've kind of done the wrong thing, because now you have this sort of double interface, right? You have uh, in the case of, say, driving a car, right? You have the steering wheel, you have the physical brake, and now you've got a robot that has to have actuators that can turn the steering wheel, and has actuators that can hit the brake. Why don't I just connect things directly?
Right.
The microprocessor can turn the motors that turn the wheel, and so on. As soon as you have succeeded in building a general purpose robot that can do everything, you don't really need the general purpose robot anymore because people don't use those tools anymore. Robots use them. So why do you have this crazy, humanoid interface when you could just do it directly?
Right, right. Well, I was involved with the DARPA Grand Challenge, and a friend of mine joked. He said, "You should just build like a robot suit and get into it, and like walk into the car and pretend you're, just say that that's what the robot is." I'm like, well, I think they'd figure that out. But it's
Yeah,
interesting because like our heads are just here in the driver's seat and can only, pivot and see,
right.
and our field of view is very limited. And of course, like, why not add the equivalent eyeballs and sensors all around the periphery of the
Yeah,
vehicle and see things? And just why are we limiting what you can see based on that one sort of location within the vehicle?
yeah.
And that's
Here,
what
here.
would that's what's happening obviously with autonomous vehicles. Some put the big eye on the roof, and many put them around the periphery of the vehicle.
Yeah.
Um, yeah, so that's certainly true for autonomy. But it would be nice if you had a humanoid robot that could get in a car and drive it today. Then that's a it's a pretty valuable robot. But so rewinding a little bit, or just kind of maybe in a nonlinear fashion, going back to your earliest inspirations. Uh, at MIT and other institutions back in the day. What was kind of relay to me? What was the culture of robotics like in the '80s? Sort of like what was what was your inspiration for getting into this space?
Well, my inspirations basically it started when I got a job at the MIT Artificial Intelligence Lab because in college I had majored in physics and I expected to go and become an experimental physicist, but I couldn't find any niche in physics that I was really passionate about. So I took a trip around the world for a year. When I got back, turned out they were hiring at the AI lab, and they gave me a job there. And within a few months, I realized what my true calling was, and it was such an amazing place. There were so many brilliant people, and all this equipment too. It's great equipment that you play with and make it do cool things. So and I thought useful things. So I fell in love with robots at that time, and it was a time of transition because, as you know, there have been different waves of artificial intelligence over the years. And when you say artificial intelligence, generally what you actually mean is not artificial intelligence, but the latest fad for implementing artificial intelligence. So at one time it was expert systems. Um, and now it's artificial neural nets. So in the early days of when I started my career, people were talking about using robots with a paradigm called the modeling planning paradigm. And what that did was if you wanted a robot to do something like move a part from one place to another to its part of assembly, first off, you figured out the entire world that was in the robot's reach. And then you thought very carefully, reasoned very carefully about how to move the part. And then you told the robot to execute that plan that it had just come up with. And it the good thing about it is that it was provably correct. If you came up with a plan and nothing changed in the world, then absolutely the robot could do that thing that you had commanded it to do. And if you could not come up with a plan, it meant that it was impossible. There was some physical constraint that would make it impossible to do that plan. So that was great. The bad thing about the modeling planning paradigm was that took so long to implement it, and it was so brittle. If anything changed in the world, then the plan would just fail, and the robot would crash into something and knock something over. So about that time, Professor Rod Brooks, who was at the lab while I was there, came up with um, this new paradigm for robot control called behavior-based robotics, and he had great success with it. He could build robots that moved really fast and zoomed along at running speed, and then avoided crashing into walls. And the thing that impressed me most when I was at the AI lab was a robot built by a graduate student, then a guy named John Cannell. And this robot wandered around the lab, and it would wander into an office, and it would collect soda cans and take them off to places where they would be dispensed. And that it was a wonderful example of, I thought, a wonderful example of this modeling planning paradigm. And the robot that he used was, it didn't even have a microprocessor. It just had a bunch of different modules. Each had a little bit of computing, and you plugged them together. So the whole thing was cheap, and it seemed like it could do this amazing task really on a shoestring. And that always appeals to me. When you can do something really complicated, really, really cheap, I love that. So that's when I became enamored of this approach to robotics. And it does have its limitations. The robots that you build are basically reactive, but there's a lot of tasks that you can do just by being basically reactive. Anyway, that's the paradigm that I've been implementing through the rest of my career.
Amazing. I think, I don't know if it was a paper or a documentary. Was it Fast, Cheap, and Out of Control?
Yeah,
The that was that Professor Brooks's statement, or was that the documentary? I can't remember, but it was
so there was a movie made
yeah.
by, I think, Errol Flynn, is that what it was? Who, and he followed four sort of idiosyncratic people, and one of them was Rod Brooks, and he used the title of one of Rod's papers as the
Right.
title of his movie.
Right. Yeah. And I think, yeah, it's been a while, but I think I certainly perused that paper, and sort of the spirit of that, how to make these intelligent physical world, robotic beings in an economical sort of fashion. And I guess the spirit, was that the spirit of that carry into sort of the early foundings of iRobot, but I know there were a lot of like trial and errors. I saw a talk from Colin Angle a while ago where he said there was like 10 different business plans over the course of over the course of a few years. So
Yeah.
tell me about that. Like how did you transition from that world into iRobot, and what were the early days like there?
So first off, when I fell in love with robots, I also fell in love with the AI lab, and I thought, well, I will stay here for the rest of my career. This is so much fun doing this research and working with all these brilliant people with all this cool equipment. I don't want to do anything else. And then the lab ran out of money, and all the research staff, including me, got laid off. So I had to find something else, and it turned out I didn't know it at the time, but Rod and Colin and Colin's first wife Jill and Helen Grainer had gotten together. They'd all been students of Rod, I believe. They'd gotten together to found this company to exploit this behavior-based paradigm, which we all thought was just the way that's going to open the floodgates for robots. Robots will be doing all kinds of things. So that's kind of the way. That's what we were thinking in the early days. So it really was. iRobot was, as I understand it, was founded to exploit that paradigm.
So just if for everyone's benefit, can you kind of summarize the maybe even a more technical sense, the behavior-based paradigm, and what was the gem behind that made it what it was?
So it's basically reactive. The inspiration was insects. So in the days when I was first discovering robots, it was always the case that if you wanted to make a robot smarter using the modeling paradigm, you made it slower. You made it consider more things and take more time to think, and you sort of disconnected it more and more from the world, and that seemed bad. So when Rod came up with his paradigm, he basically turned everything on the side. Instead of first developing a total model of the world, you just have a bunch of little behaviors, and each one is watching some aspect of the robot, and each one has its own idea about what the robot should do. So when I tried to come up with examples of these things, the lowest level of robot control that I usually build is a behavior called cruise. And the only thing that cruise does is it tells the robot to go forward as fast as it can. And that's it. That's the one thing that behavior does. And you can see that there are certain times when that's really the wrong thing to do. So then there will also be a higher level behavior, and I generally call it avoid. And it often has either a sonar sensor or infrared sensors that are looking forward. And mostly this behavior doesn't do anything, but if it sees a wall, say, or if it doesn't know what's happening, right? It just knows that it gets a signal from one of its infrared sensors. So if it gets a signal from the infrared sensor that's on the left side pointing towards the left, well, maybe there's a wall there. So then the avoid behavior commands the robot to turn so that it turns away from the wall. And so now you have two behaviors. You have cruise, which just says just go forward as fast as you can, and you have avoid, which just says spin to the right. And you must also have another piece of software called an arbiter, and the arbiter just looks at the behaviors that want to get control of the robot's motors, and it gives control to the behavior that has the highest priority. And generally, the priority is just fixed.
Okay.
So you decide in the beginning which behavior has control under which circumstances, and if that behavior circumstances come up, then it gets control, and the robot does the right thing. And if you add a whole bunch of these behaviors up, you get emergent behaviors. In the classic case of Roomba, right? It just has well, I think it actually had 57 elementary behaviors, the very first one. But the behavior that emerges is that the robot wanders around your living room, and even though it might wander into a tight corner or something, it always comes out, and it just keeps wandering until the floor is clean.
It's fascinating. And so all these priorities were sort of fixed. There's no sort of analog or continuum where they're weighted in any way, or
There have been people have dabbled in that,
yeah.
and I've dabbled in that a bit too, but I've never found a situation where a simple hierarchical behavior didn't work the best. And I don't want to skip the most important thing about this is it's also cheap, right?
Yeah.
A cheap 8-bit microprocessor is all that you need to implement a robot like Roomba. And the first one, I think we paid like 30 cents or something for our microprocessor back in the day.
Wow.
And it was perfectly adequate.
And it sounds like verification of each of these individual behaviors is obviously easier, and the verification task presumably is therefore viable and economical.
Yeah, the first part's easy. You can show that each behavior works by itself. The thing that's harder is, okay, what happens when sort of everything happens at once, or when you switch rapidly from something that triggers one behavior to something that triggers a different behavior, and they have to play together nicely in the real world. And that's the thing that takes all the time, making sure that in the real world that there's not some kind of conflict between the behaviors. It
And
can't be done.
yeah, there's some combination of, I guess, at any one point in time, if you have 57 behaviors, I'm not sure all of them could be triggered, but some subset thereof could be triggered, and then you have to what's the combination of these, I guess, that how do you know the safest one is going to subsume or take precedent over the others, right?
Yeah,
I guess.
and a priori you don't
Yeah.
generally. You generally have to watch the thing working in the real world. That was one of the things that in the early days when we were working on Roomba, we thought about doing simulations, but simulations wouldn't really have helped because you simulate something, you only simulate the things that you think to simulate, right? And the real world is filled with so much more details than you might imagine. So there was really no substitute for us for trying the robot in the real world. Since then, I think simulators have gotten a whole lot better, but you still only simulate the things that you think to simulate.
Right, right. So as these behaviors scale, if you want to scale the complexity of behaviors and you go from 57 to 1,000 or to 100,000, I don't know, right? Is that does that sort of approach scale, or does it just sort of like level off at some point because of the verification? Maybe, I don't know.
Well, I expect that I haven't gotten there, but I expect that it does level off at some point. I don't think well, in some sense, it scales to human level because in some sense, we're doing something like that. But there's probably a different way of implementing the whole thing. And maybe that's what artificial neural nets are doing now. And maybe they're better at it. But
That's what I'm wondering, if it could be related in some way to where the behaviors themselves stand on their own, and then the weight, like the decision as to which ones are sort of the arbitration, if you will, is sort of neural net based. I don't know if you ever, if anybody sort of went down that path to sort of decide which one takes over, and then therefore you could maybe add more because you're training it presumably against us, maybe even a simulated world now that has some of the, more of the use cases in which it would be exposed.
So I wish that I understood the subtleties of artificial neural nets and large language models and such like. Those kind of came along too late for me back in the early days at the AI lab. We all had the opinion that neural nets were not going to ever amount to anything. It's
Well,
surprising now since they've taken over everything.
well, there's certain things, yeah, that they're obviously, I don't think they're so good at. Like I would just say in autonomous vehicles, you do have this very heavy, fast moving vehicle with a lot of, therefore, physical, power that can be exerted in the world. And you do really seemingly want more determinism and verification and validation at the end of the day, but these probabilistic neural networks are not verifiable and validatable. So,
Right.
so that's where the determinism of an architecture that you mentioned appeals. But then then it's the question of, okay, you've got determinism, but then how do you scale? And that's maybe the trade-off.
Yeah, if I were starting my career today, I'm sure that I'd be totally fascinated by the artificial neural nets. I'd think this is the way to do it.
Well, yeah, so in the going back to those early days, what were some of the earliest, like what was the first business plan, if you will, the first idea for iRobot to
Well, I didn't actually join the company until they had been in operation for about a year, but I know some of the early business plans, and one that we spent way too much time on was the notion that, well, what we'll do is we will design a lunar rover, and then either we will sell the rights to some movie company to use the lunar rover on the moon, or we will have people pay on Earth to drive the lunar rover around the moon. I mean, that was crazy, really.
it sounds fun, but
Oh yeah, great fun. Um, and then there was another moonshot thing that we did. There was the Star Wars system, right? That President Reagan was promoting, and when that kind of didn't go anywhere, the people who had been working on it wanted to do something with the equipment that they had developed. And one of the things that they had developed was this brilliant pebble. They called it a brilliant pebble that was supposed to zoom into the path of an oncoming missile and blow it up. So they thought they would repurpose this and send their brilliant pebbles to the moon, and as a cheap way of exploring the moon, I think. And they got involved with what was called Robotics in those days, but they got involved with iRobot, and we built this little six-legged walking robot that was going to sit into a canister on one of the brilliant pebbles. It was going to be landed on the moon. It would kick it out. The brilliant pebble would kick out the canister. The robot would stand up and start walking around. So they actually did a test. We got as far as doing a test. I think it was Edwards Air Force Base, and so they launched this thing inside a building, and it went. I didn't get to go, but I saw the video, and the thing went up and wandered around for a while, and came back down and landed, and everything worked just perfectly. Right, the door. What the robot had to do, I wrote the program for this robot. What it had to do is had to kick its leg up, and when it kicked its leg up inside its little canister, it popped the canister open and then stood up and walked around. So, and it all worked brilliantly, but then nothing ever came of it. Oh,
and I guess yeah, I guess I want to talk more about, like, what are the impediments to some of these things? Obviously economics or political or a combination thereof. I don't know.
uh, for the moonshot ones, it was the economics were brutal, right?
Yeah.
I mean, we might be able to build a robot, although we didn't know anything about building space qualified robots. But then, how do you get it to the moon? That's another whole big problem, and we didn't really want to address that. So most of the plans, the business plans that we had come up with, failed in some very basic market-based way. So, so the way that the company survived, since none of the business plans really worked out, um, none of the grand business plans really worked out. What we did was we did basically contract engineering, in a sense, contract engineering, because we were building robots as demonstration projects. We would try to get a company to sponsor us to build a robot for them. We also came up with a line of research robots that we tried to sell to universities and other folks. So basically, the company went into a mode where they just tried to keep the lights on and the doors open, and that
Oh yeah.
lasted for several years.
Well, yeah, no, well, that's well, it's a familiar story. I mean, well, it's if it's not familiar to a startup company or any company, it's because they went out of business because they didn't
Yeah,
do that,
yeah.
and to keep the lights on. But and I guess venture capital, was there any early? There was no venture capital much or back in the
So
day, or
no.
yeah,
In the first several years, so I joined in '91, and from then until just before Roomba, just before maybe the venture capital came when we started working on it. It was like 1999, I think, when we first got any venture capital. So we had like 8 years when it was hand to mouth.
yeah, yeah. So did the Roomba precede Packbot, or were they? Which one came first?
They happened almost exactly the same time.
Okay.
I'm sure one came a little bit before the other, but both were in development at the same time, and both became successful about the same time.
Yeah, yeah. And now, but you were mainly focused on the Roomba early on when it first came to be.
Yeah, I like Packbot initially was teleoperated, right? And I like autonomous robots, so I want the robot to work by itself.
Right.
I want it to work so I don't have to.
So what was that? Now I know um, Rod Brooks, was very much into. I remember seeing pictures of like like the faces, like the robot heads or whatever, with the expressive expressions, and uh and so he was doing some pretty advanced stuff. Was he um involved with you on sort of the early incarnation of the Roomba, or was he like opposed to it? Or I maybe you don't have to comment on it, but it just seems like that, you know, he was working in sort of one area, and I don't know like if those were connected in any way or
So the way that I look at it, Rod basically made Roomba possible by developing the the paradigm that we use to program it, but he pretty much had nothing to do with the invention or building the robot itself. And you can look at the patents, and you'll find the names of the Roomba team all over them. And I don't think Rod's name appears once.
I'd say. And so what was so tell me about like the birth, if you will, if you wouldn't mind, of the Roomba based on where you all were at that moment.
Well, it's a bit longer story.
Okay.
It starts at the Artificial Intelligence Lab, and it starts in 1989. So I was on the staff there then, and Rod's group decided that one January at MIT, January is the independent activities period, so there's no classes, so people there's a variety of things to do, and one of the things that the AI lab used to do is that they have an AI Olympics. And so that year, Rod's group decided that they would have, as part of the Olympics, they would have a robot talent show. And what that meant was that they would get kits of parts like Lego and sensors and microprocessors and such like, and they would hand them out to anybody at the lab who was interested. And that person or that group would use them to build whatever kind of robot that they wanted. So I lived alone at an apartment in Cambridge in those days, and I wanted the floor to be clean, but I don't want to clean it. So I thought I'll build a little robot that cleans the floor of my apartment. So I worked diligently for the whole month of January that year, and at the end of the month there was the talent show that they had in the faculty club at MIT, and a whole bunch of robots, like maybe 20 or so robots performed. Some of them didn't actually perform. Some of them, the developers sort of held them in the hand and said what they were supposed to have done. But I was luckier than that. Mine actually worked. So it went around the floor and it picked up some dirt. And I thought, well, why not? It looks like you can actually build this thing. Why aren't there any? So I didn't have any interest at that point in starting a company. I loved working at the AI lab and I wanted to stay there. And it was only later that, um, we all got laid off. But when that happened, I knew a guy who worked at one of the very few robot companies that existed in the country at that time. There was a company called Denning Mobile Robotics. And he got me an interview with one of their vice presidents. And it went well. They hired me and I started working there. And Denning made these big robots. They were the flagship of their product line was the Denning Sentry, and it was a sort of refrigerator-sized robot that was supposed to roam the halls in an office building or a warehouse, after hours and track down predator or the people who break in, right? But they were really expensive, like $75,000, maybe said. And I thought, well, I've just learned this great new paradigm. You can build really cheap robots that do really useful things. So I convinced this other guy to work with me, and we got permission to do it as a back burner project. So we worked on this for several months. And in December of that year, we were finally ready. We showed the little robot bouncing around the floor, picking up dirt to the whole company. And we thought, anybody with half a brain can see, what the promise of this thing is. This has changed the whole Denning business plan, right? And then 10 days later, I and the other guy both got fired because it turned out that the president of Denning just thought we were playing with toys.
Oh, wow.
So fortunately, within about a month or maybe two, I got hired as the first full-time hire at iRobot. And of course, all of my colleagues thought, yeah, a little robot that cleans floors, that'd be great. But they didn't have any money, right? They were living from hand to mouth. There's no way that you could spend money to develop something like that. So it basically got put on the back burner.
Wow.
It wasn't until 8 years later, after we had done this other project, for a big cleaning robot, big, 500, 800 pound cleaning robot that hadn't gone anywhere, that my colleague at the time, a guy named Paul Sandin, said, I have an idea. Why don't we build this little robot that can clean home floors? So I had never told Paul about my previous experiences with little robots that clean home floors. So it seemed like the time was right because finally iRobot was in a more secure financial position, so they could possibly take on something like the development of Roomba. So it was at that point that once again, Paul and I got permission to spend 2 weeks of our time and a budget of $10,000 to develop a little prototype of a robot that cleans home floors. And once again, we just demonstrated it to the whole company, but this time, instead of getting fired, they decided, well, we'll put a team behind this and try to actually develop it as a product. So that's sort of how it got started.
Wow, that's amazing. And so what did this prototype kind of like look like? I don't know if you'll be able to send a picture, I'll put it up, but
yeah, it looked like a big white hockey puck.
okay. So was it bigger than the current Roombas or the
No, it was about the same size.
Okay.
I mean, there are constraints that, if you look around, there's not a whole lot of robots that are available today, cleaning robots that are a whole lot bigger or a lot smaller. We pretty much figured out the size that it had to be because it had to get under the toe kicks in a kitchen. We wanted to go under that. We wanted to go under furniture, and we wanted it to go between the legs of dining room chairs. And that dictated that the diameter be somewhere around 14 inches and the height be somewhere around 3.5 inches.
Right.
So
right.
that's
So
what it was.
Yeah, that constrained the dimensions and what year was this roughly? Is this?
So this was 1999 when we
99.
proposed Roomba.
So were lithium,
No.
batteries? No. So your energy density for the batteries was pretty low, I guess, right?
Yes,
So
that made the whole
what was
thing
the
very
first
dicey.
battery? Yeah, okay.
I think we used nickel metal hydride in the first iteration, but that made everything really hard because we had it needed to run. It had to bounce around until the floor was clean, so it needed to run for like on the order of an hour, um, and it could only be so big because that's all the space that you have. So it was really hard constraints. And the way that we succeeded was instead of using the idea behind the Roomba, at least the technical idea, was that we would balance the energy budget by not using a vacuum. We would only have a floor sweeper mechanism, which
Ah,
is way more efficient, energy efficient at cleaning than a vacuum is. So we developed the whole concept just using the carpet sweeper mechanism. And
okay.
then our our project manager, a guy named Winston Tao, said we should have a focus group. And we went to the focus group, and it's just the classic thing, right? The engineers are all in this darkened room. There's a table in front of you, and there's snacks and stuff on the table, and then there's this one-way mirror, and on the other side are bona fide real people, average normal people, and we had our facilitators there, and she was taking the folks through the demonstration. And she had asked them, what do you what would you pay for a robot that has these capabilities? And a lot of people were really skeptical that such a thing would exist, such a thing could be done at all. But if you could, they'd pay. They was kind of all over the map. There were some people who said like $100 or less, and a few people who said 200, which is what we wanted to charge, and one or two people who said like 1,000. We thought we like those people. So anyway, she then showed them the robot working, and I think she probably put some dirt down and had up the dirt so that people could see that it actually worked. Um, and when they saw it working, they assumed that it had a vacuum. They assumed that that's the way it worked. But she had very carefully not told them how it worked. But then she did tell them and says, no, it just has a carpet sweeper mechanism. And then she asked them again, how much would you pay for it now? And everybody sort of cut their estimate in half.
Oh,
So
wow.
that was a huge shock to the engineers because we had decided the enabling technology for this new product is that it uses a carpet sweeper mechanism and not a vacuum. So, but now if it didn't have a vacuum, nobody would buy it, right? We couldn't make any money selling it. We'd lose money on every robot if we charged half what we were planning to charge. So then we had to go back to the drawing board basically and decide how to fit a vacuum into the robot. We could have made a vacuum that didn't do anything. That would have satisfied the marketing. That would have been fine. But no engineer wants to do anything like that. So we actually did find a way by having this little micro vacuum, the very, very narrow inlet that has the same air velocity as a regular big power hungry vacuum. But our vacuum only consumed 3 watts, whereas the one that you plug into your wall may consume as much as like 1,400 watts.
Right, right. Well, I think I was an early customer. I can't remember, I've had more than a couple Roombas over the years, but I do where was the first commercial model sold? Did it just have the floor sweeper, or what did it have the vacuum in it?
No, it had the vacuum. We
Okay. I can't
wouldn't have been able
remember.
to sell it without
I
that.
see. I see.
Although there was another one that I had a lot of hope for that was called Dirt Dog, and you were supposed to use it like in your shop to clean up sawdust and all. And it was less. The Roomba was launched at like $200, and I think Dirt Dog was 150.
Hmm.
But they discontinued Dirt Dog after a while. People,
Right.
even
So,
for that other purpose, they didn't
so,
want it.
so the vacuum was sort of in this case, the most power hungry portion of it, or what was it, the motors that drove the thing?
No, it was the main brush. The main brush motor
Okay.
was the
Okay.
thing that used almost all the power. It didn't take a whole lot of power to just move the robot around. But the brush, you have bristles and you have a carpet, and to turn the bristles past the carpet, it just takes a certain amount of power.
Okay. And you had this NIMH batteries, I guess.
Yeah.
And And that gave you the hour runtime roughly,
It
or
did. Yeah,
okay,
it did. Of course, it depends on the floor type, right? It would run maybe an hour and a half, 2 hours if you just put it on a tile floor. Um, and if you had, a plush carpet, maybe it was 45 minutes. It totally,
yeah.
yeah, it's related to the surface type.
And you could plug it in to charge it, as I recall, and then or you could
Right.
pop the battery out and put another one in. It was fairly
Yes,
easily, right?
yes,
Yeah.
both of those things were possible.
Yeah. Wow. So that was for production unit version 1, I guess. And the sensing at that point, what like I guess what was it? What were those looking like?
So the primary sensor was a bumper, and it was a
Mhm.
mechanical bumper. So you push on the bumper, it closes. Well, actually, it worked by having these optical switches. There was this optical brake beam mounted on the circuit board, so that when you push on the bumper, it broke that beam, and it knew that the bumper was touching something, and it knew which side of the bumper was touching. And then we also had we didn't want to fall over a cliff or go running down the stairs, so we had these infrared sensors that looked down to see if there was a floor beneath it. And we had a second level of sort of redundant level of an attempt to not fall over cliffs. When there was there's two drive wheels and a caster, actually a roller in the front, and the all the wheels were mounted on springs, such that if one ran over the edge, the wheel would go down to the limit of its travel, and there was a switch, the drop switch there, the wheel drop switch, and if that tripped, then the robot would shut itself off, thinking that it's got one wheel hanging over the edge and it shouldn't do anything else.
Right, right.
We also had, I don't remember, actually it was in the first model or a later one, but we also had a dirt sensor that tried to detect if dirt particles were being picked up. And if they were, then it concentrated on the area where it's currently cleaning.
Wow, wow. And so it's interesting because the concept of being a roboticist or somebody who wants to write the software and the sort of the intelligence behind these systems, um think you're thinking about, I'm going to write like this new brain, this new intelligent way to control a machine. But then you get pulled into something like, how does it vacuum? And that's not something, I presume, like you were thinking, hey, I'm going to learn how vacuum cleaners work. But you inadvertently get pulled into these other kind of non-robotic things that are fused with the robotics in some way. And like, what kind of challenges does that pose? I mean, or do you go out and seek experts, or do you just kind of figure it out?
Seeking experts might have been the smart thing to do, but I'll tell you, the thing that one of the things that I've always loved about uh, working on robots is that they always force you to learn new things.
Yeah.
Um, you can't start with presumption about the solution, right? You have to develop, you have to think about, you have to rethink the solution from the ground up, and you try to come up with the simplest set of problems to solve that you can. And if a problem it turns out to be too difficult, then you have to sort of redo the design so that you can do it without solving that problem. So yeah, we did have to learn about floors and how they're cleaned. And sadly, I didn't learn how a carpet sweeper mechanism actually works until like 2 weeks before we had to tell the factory to, yes, turn on the floodgates and start producing Roombas. So another thing that happened, we've been working on Roomba for probably about 2.5 years at that point. And we were just about to get to the point where we would send the files, the final files, to our factory in China, and they would start cutting steel to make to make, well, it was going to be 25,000 initial Roombas. And then once again, Winston Tao, our very savvy project manager, said, let's do a test. So, and the test that he wanted us to do was as simple as you can get. Put some dirt on the floor, point Roomba at the dirt, turn it on, and see what happens. And we did that, and Roomba passed over the dirt and didn't pick up a thing.
Oh,
And this
wow.
is like 2 weeks before we're supposed to, turn on the factory. And we were all amazed, right? What could go wrong? It's not like we hadn't done tests. We'd done hundreds of tests of Roomba's cleaning efficacy with slightly different earlier versions of the thing that we were building, and then suddenly it didn't work at all. So there was panic set in for a bit, and it turned out it was entirely my fault. Ever since I had built that first robot back at the AI lab, I had not actually understood how carpet sweepers worked. I thought that, there's this brush and the brush picks up the dirt as it goes around. And then on the far side, there's this comb and it combs the dirt out of the brush and it falls into the dirt collection cup. That is not how they work at all. That completely, a lot of them don't even have the comb. What happens is when the bristles sweep past the floor, there comes a point where they flick, right? They start to leave the floor and then they flick. And when they flick, any little dirt or whatever that's in front of them starts bouncing around. And sometimes it bounces back into the dirt cup and it picks it up. And sometimes it bounces back onto the floor. And if it bounces in the right place on the floor, then the brush gets a second chance to pick it up. But if it bounces behind the brush as the robot's moving forward, then it's lost and it doesn't clean. So it turned out that the mistake we had made was we had this shroud that wraps around the brush, and in the most recent model, we had inadvertently made the shroud wrap around a little bit less. And so finally, after panicking and staring at the robot and staring at other carpet sweepers and staring at the vacuum cleaners and all, I finally realized what was actually going on. And when we figured that out, then it was just a matter of extending that shroud around like that much, a quarter of an inch or so, and then
Wow.
everything worked fine.
It's amazing. Yeah, the littlest, the littlest of things that, it's
Yep.
not obvious or not easy to think of that just affect the efficacy of such a thing. And you've built this this amazing robotic machine, and it's just one little tweak that's the difference between it
Every
accomplishing its mission and not.
everything counts in
That's
robots.
amazing.
Everything counts.
That's amazing. That's a wonderful story. And thank you for sharing that, because like
Sure.
that's those things are inspiring because you encounter those things as a roboticist or as an engineer. Often you forgot that semicolon when you're programming something, and
Yep.
uh and that mattered, or you indented too far if you're using Python. And so like the manufacturing, like how big. Well, just many things run through my mind, like the economics, like as you're making this robot, you have a price target in mind. A lot of
Yeah.
engineers, well, not a lot, I don't know. Some engineers don't think of cost or price or what have you. And but you obviously that had to be front and center with your decision making and what parts you chose and the design of this, I presume.
Yes, absolutely. So, like I said, my colleague Paul Sandin had came up with this idea for, well, I'm gonna build a little robot that cleans foam floors, and we had known that other people had tried this before, probably quite a few times, and we were wondering, so why have none succeeded? And one of the big reasons that we came up with is because everybody was charging too much. They were thinking that instead of building a product, they were inventing the future. So, roboticists tended to want to throw as much technology as the problem as they possibly could. So we decided we would go exactly the opposite way. And then you throw much technology at it, and then the price just keeps going up. We would start by setting the price. So we set the price by looking around at, what does a manual robot vacuum, what does a manual vacuum cost? And in those days, the great majority of them were between like $50 and $150. So our first thought was $100. We will build a robot and it will cost $100. It turned out that was a robot too far. So we settled on another price. We thought, well, maybe people will pay a little bit of money because it's a robot. They don't have to do the job anymore. We didn't think they'd spend 10 times what they pay for a manual vacuum, but we reset the price at about $200, and then we were able to do it.
Wow. Wow.
And that drove every decision. The fact that it cannot cost more than $200, that drove every decision.
And so that was the cost. So when you cost this, you're sort of you're looking at sort of just like the retail effective retail price, or some sort of quantity pricing of these things that you think you might be able to get, I guess, at that point.
Yeah, we used the rule of thumb. We wanted the retail price to be $200, which meant that our bill of materials had to be $50.
I see. So 4x. Yeah.
Yep.
Hmm.
I think we actually hit 52, but
okay.
Almost made it.
Wow. But that's so that's of course buying in some quantity and with some understanding of how much it would cost to have your contract manufacturing.
And one of the things that we had to do was when you have a solution that you can buy off the shelf, the tendency is, well, we'll just buy that and stick it in the robot. And so there's one example of where we couldn't do that and what we had to do instead. So like I said, we didn't want the robot to fall down the steps. So it had to have some kind of a sensor that was pointing down and looking at the floor. And there's a company called Sharp that manufactures these infrared sensors that will tell you how far something is away. So we thought about using that. But in those days, the cheapest sensor was probably $1 or more. And we decided that we couldn't afford to pay more than 10 cents for our sensor. So we couldn't use it. So we had to invent some new way of doing it. So we invented this cheaper way that just used an infrared emitter and an infrared detector, and they were pointed in such a way that their field of views intersected where the floor was supposed to be. So if it was above that, if the floor was above that or below that, then it would say there's no floor here and it would stop. And it turned out to be about 10 cents rather than $1 or $2.
Wow. And so, yeah, all that work to shave 90 cents off of per unit price, but I guess over at that time, 25,000 and then many, many more units, it's going to matter.
Yeah.
So tell me a little bit about the manufacturing process. Like how do you all figure out the best way to manufacture such a thing, and how difficult is that in the world of consumer robotics, like picking how to do that and who to do it? And
so that turned out to be a critically important and really difficult. So we got good advice from some consultants or maybe some employee that we had at the time about which factory to go to. And the factories that we looked for were ones that had experience in making products and were sort of looking to move up, looking to make something a little more difficult than what they had been making before. So there was the company that we settled on was one called Jetta, and they had made a lot of those toys that you find in Happy Meals, right?
Okay.
They had been doing that, but the company had been founded by engineers, so they wanted to do something more complex than tiny little mechanical things that go into the Happy Meals. So they were motivated to work on a robot, right? That sounds cool, and it would increase their stock in a sense. So we settled on that factory, and then since none of us had experience in building consumer products before, that was a big education. We got to the point where we thought that everything was done. We thought that we had, the files were exactly the way they wanted them to be. We specified all the components, all the all the pieces of Roomba, and we would send them off to the factory, and then they would just make it. And then we hedged our bets a bit by our engineer, a guy named Elliot Mack, who had done basically all of the CAD for Roomba. We thought we'll send him off to the factory for a couple of weeks just to make sure they get started well. He was there for 6 months.
Oh,
He was
wow.
there for 6 months. There were every day there was problems that we hadn't thought of, and little things that made exactly what we had done not work. And we had to do it a different way.
And
So
the factory was in China.
the factory was in China. Yes.
Yeah. So he was 6 months in
So
China, and
he got to come back a couple of times, but most of the
right.
time he was stuck in China working on this thing every single day, trying to make it manufacturable.
Wow. Like, so I don't know. Can you share like what's an example of like a hiccup that you don't expect from the factory?
One thing that happened was it has to pass this FCC test, right? So in particular, motors are often a problem because these are not brushless motors, right? These are brushed motors, and when the commutator turns past the brush, it makes a little spark, and the spark generates all kinds of electromagnetic noise. So we hadn't anticipated that. We were just going to solder the wires that control the motor directly to the motor, but because it didn't pass the FCC test, we had to add this little circuit board to the back of the motors that has some capacitors and maybe a resistor or two that suppress the noise. But when you add that, then it bumps into the plastic, so we have to redo the plastic.
Oh,
So that was just one thing. Um, um, there are a number of others that kept
yeah.
us busy.
But just that, like, that's a great example and another great story, because here now you've designed this and you've tested it here,
Yep.
and now it's over in China being manufactured, and you have to choose a different motor design and right, a different part essentially,
Yeah, a different part.
a different part. I guess the going brushless wouldn't have been an option because those are expensive.
Oh no.
And and many probably maybe other issues, but like, so you have to, and now you're back to, now you got to change like the shape of something, and you just spoke to how that affected the sweeping. So like, how do you, like, how does one run through any sort of testing that you can possibly do to kind of do, because you probably tested a bunch of scenarios for production. Now you've got to regression test something,
Yeah, and when we did that, we set up at the factory. We set up these sort of apartment buildings for Roomba,
Okay.
and each one had about probably about a 2 feet by 4 feet, or maybe 4 feet by 6 feet, or something like that. Um, and it had a little carpet, and it had a carpet on one side, and I think it may have had tile on the other side, and had a little threshold that it had frost. And and of course you can't just rely on batteries. You want to test these for a long period of time, so you have to have a wire, a power wire coming down to the middle, and you have to modify the robot so it can take the power through the wire coming, the umbilical cord actually. And so we had stacks of these running for a long period of time, and that was basically how we figured out that how we made the whole thing work. One other example that comes to mind was that when we first started testing the gearboxes that controlled the brushes, right? There's two counter rotating brushes, and there was a gearbox that connects the two brushes and connects the main brush motor. And when we started testing, that worked fine. And then at some point, the gearboxes started melting. And we didn't change anything, but what had happened was there is a little shaft that the gears have to spin around, right? And when they first started doing their manufacturing, and as they were doing these tests, they would take the shaft starts as a steel rod, and then they'd use a hacksaw to cut it into little pieces and make the little axle. And then somebody decided, well, it's a whole lot faster if we just use power shears to chop the things, to chop the steel rod. But and you look at the two pieces, the one that's cut with a hacksaw and the one that's chopped with the power shears, and they look the same. But in fact, the power shears deform the axle just a little bit so that the friction increases. And now when the plastic gear spins on that metal shaft, it melts. It gets hot and it melts. So that's,
Oh man, that's amazing. These are just true tales of heroism and horror. Um,
yeah.
wow. And then, you know, and so that's the factory story. And then I guess at some point these I guess are shipping these things to back from, you know, is that a costly time, you know, time consuming endeavor, having the shipping and the
Yes.
unloading them, and so that adds cost and time, I guess. And
So our plan had been, there was a slow boat and a fast boat. So our plan had been, we arranged a schedule such that the slow boat would get our product back to the United States in time for the launch that we were planning for, like September of 2002. But when Elliot was in China, these problems kept coming up, and it took so long to fix them. But eventually, the slow boat had already left, and we weren't ready. And then the fast boat had already left, and we weren't ready. So the only way we could get them here was put on an airplane. So we paid to have the robots flown
wow.
from China back.
And
But
how
they got
many
here in
were
time.
there? 25,000?
So the total order was 25,000. I don't know that they all came at the same time, but the first ones, yeah, the first ones got to ride the airplane.
For 2002. And was there like a CES deadline or something at that point too for 2003 coming up in January? Or
Oh, I don't think that was a consideration at that time.
okay, yeah.
Yeah, I don't remember going to CES.
Yeah.
So
I don't know. I just was curious because I know sometimes that drives additional stress for
yeah,
product launches.
we had plenty of stress drivers.
And then they come in, and so, well, then I guess for the holiday season, I guess you were selling them then at that point, right? Who was
Yeah.
selling them? What was there like a key store that was selling them at that moment?
So
Brookstone
it
or
started
something?
off in Hammaker Schlemmer and
Okay.
the Sharper Image. Brookstone may have already also been in on it. So they were the first ones. And then at some point they went to Bed Bath and Beyond, and after a bunch of a long period of time, they finally got into Sears, which we thought was really big. They people loved them right from the start. And then there was a couple of things. So let's see. They loved them the first year, but then the second year, iRobot made a much bigger order, and they found out late in the year that the warehouses were full. They weren't selling as much. And then, completely beyond our control, Pepsi put on this national commercial that featured Dave Chappelle, and it had a robot, a floor cleaning robot that ate his pants in the commercial. And after that commercial aired, Roomba sales took off again.
What?
I don't get it, but. And then the other thing that happened was they started breaking. The robots started breaking. They found many different ways to break. One of the ways that they broke was there was a tread that goes around the wheel, and the tread would split and come off. And spontaneously, our customers figured out how to fix it. And there was like a Roomba forum that developed online. People saying, here's how the glue that you use, and here's how you use it to put the tread back on the wheel. And other things happen too. A Roomba needs to know, one of the things that it does is spiral around, and it spirals in an increasing circle. So there were encoders on the wheels that tell you how far the wheel has turned. The encoders were this little, it looks like sort of like a gear, except that it's a piece of plastic with slots in it. And then there's a brake beam that looks through the slots, or the slots turns. It knows how that the wheel has turned. But the motor was connected to this feature and the rest of the gearbox through a rubber belt. And as the robots aged, little flecks of rubber would come off of the belt and sort of coat everything inside the motor module, including the brake beam sensor that we were using to tell that the wheel was turning. So when that got clogged, then instead of the robot, wandering around your floor, it just did this sort of back and forth dance.
Yeah.
So that was a couple of ways, but we were really, really fortunate in that people liked the robot. In spite of its flaws, they liked it. And there was one of us was we had to man the customer service line, and one of the engineers manning the line got a call from this guy who said, "So I have had 4 Roombas and they have all failed. Would you send me the 5th?" And that seems unimaginable that somebody would accept that they had bought this product and 4 of them had failed and they still wanted a 5th one. But people, inexplicably, people loved the robot, and that saved us because, like I said before, none of us had built a consumer product before, and although we tried our best, we just didn't know all the tricks, and that made our robots initially unreliable. But people loved them so much that we survived that period of unreliability, and the next models got a lot better.
And how does one, so you get information presumably through your customer service lines and online ticketing, I guess, of some sort, forums and what have you. How do you ingest all of that feedback and figure out what to prioritize for the next rev, the next version?
Well, the things that make it break the soonest is what you fix
Okay.
first.
So there's like a committee that, a group that decides this, and because you can't fix everything, I presume. I mean,
No.
yeah.
So pretty quickly, there was a second iteration of the robot, and basically it fixed the things that had shown up the most as breaking. But after that, so there was the very first Roomba, and then there was sort of a half an iteration after that, where we fixed some of those things. And then another year or two passed, and we had a new version of Roomba, and its reliability was way better than what that original crew
Yeah.
was able to do.
Well, then at some point, I guess lithium batteries became, at first there was some in consumer products, there was a little concern about fires with these lithium batteries, but then that kind of stabilized. But when did you make the switch to the higher density? And I
So
presume that
that was
adds.
after my time. That was after my
Okay.
time. So I really only worked on the first iteration of Roomba, and then I thought, check that box off. I want to do something new, right? I want to build a new revolutionary robot.
I see.
So
I see. So you were, but still within iRobot, working on the next thing, or your next thing. Is that
I was, well, a funny thing happens when a company becomes successful. When you're a startup, the only thing that you're trying to do is come up with a business plan that works. And you are forced to take huge risks in order to do that. And I'm sure you're aware that most startups fail, right? Like maybe 10% of them actually actually realize their founders' dreams, and 90% of them fail. But and iRobot had trod that path for a long time. We were a startup for more than 10 years before we finally had any success. And as soon as the success came, what I thought was that we've always said we want to be the robot company. We want to build all kinds of different robots for all kinds of different applications. And now when we have an income stream from Roomba and from Packbot, we'll finally be able to do that. That was not what happened at all. Instead, what happened was more prudent economic types say, well, now you have a business plan that works. Stop taking these crazy risks and just exploit the thing that you have, which, that's fine. And that is the way that you make money. But you don't then develop the next thing. And so it took me 4 years to figure out that iRobot did not want to do any more revolutionary products. So then, since I did, I I had to leave to found another startup.
Gotcha. And that was was that Tertill?
No, that was Harvest Automation.
Okay, you from Harvest. I know you were involved with Tertill, I thought. Tertill.
Yeah, that came later.
Okay, that was later. So Harvest was yeah, which is, well, speak. I kind of know what it is, but in your words, what was Harvest's mission?
So what we settled on doing after we had left iRobot, we didn't know what we were going to build when we left, and there were like 5 of us originally who left iRobot to found this new company. One of those folks went off to do something else, so there was this core team of 4 people, and we tried to find another application in robotics. And I was looking for something that was like a little bit harder than floor cleaning. And I found this wonderful application in the nursery and greenhouse industry because there's something like 1 to 2 billion potted plants sold every year in the United States, produced by this industry. And there's a step in the production of those plants, which is very labor intensive. So at first, when you put you start off by getting a pot, you stick a sprout into the pot, and you stick these pots outside on a growing bed so that the plants can grow. But after the plants have started growing, they start, spreading out, and then you can't let them interfere with each other or the plants will damage each other. So the step that has to be done is you have to take all these pots that are setting, on vast fields and move them apart. And that step is called spacing. And to accomplish it really takes an army of people. So when we first encountered this, we thought, well, it's a perfect job for robots, right? Robots should be doing this. Why people breaking their backs doing this kind of thing? Let robots do it. So that was the thing that we built, and it satisfied checked all the boxes because it was sort of one step more difficult than Roomba. The robot didn't just wander around. It definitely followed the edge of the bed to the pile of pots that were too close together. It found a pot, it picked it up, so it had one more actuator than Roomba. It actually had to pick the thing up, and then it carried it down to the other end of the bed. It noted the pattern of pots that were already there, and the robot put the pot that it was carrying into the proper place in that pattern, and it went back and did it again. So it was a great project, and it worked really well.
That's interesting. So what, I guess, where did it go from there? As it and what were some of the, I guess, the challenges, I guess, was it, economics again or something?
The challenges were economic.
Yeah.
And another challenge, I learned something from this process. One of the things that helped us out a lot on Roomba was that all of us were experts in our domain, right? Because we all had floors to clean, and we had all cleaned those floors many times. So we knew how to do that. When you go to a different domain where you are not an expert, the only thing that you can do is you can talk to the people who are experts, right? You can talk to your customers. And we did that extensively. We talked to the customers. We talked to the trade organization that's behind Nursery and Greenhouse. We visited sites many, many times, but the customers can't tell you how they're going to use a product that they have never used before, or rather they will tell you, but they're just guessing. So what we thought when we were developing this product was that they were going to use it the same way that they would use people, in that they would use it 2,000 hours a year. So it turned out that once our customers had the product, they used it 500 hours a year. And what that meant was that the price that we had left, the price had crept up to a point that it was 4 times too much.
Right.
So, we did have a bunch of customers, but we didn't take off the way that we needed to as a VC-backed company.
Interesting. It's an expert sort of communications dilemma, and that if you've been doing something long enough, you forget to communicate. In this case, it was your customers, or I know I suffer from this. You forget what somebody else doesn't know, right? And so
Right.
it's or you might abstract something, and so and some of those details, as we're with robotics, as you've highlighted too in the manufacturing side, amongst other things, are critical to. But the economics I always thought were interesting with agriculture. If you're making food or producing food or something else that's a commodity, the margins are very low,
Yeah.
and the ability to pay for the NRE that's needed to, like, even launch a robotics project, um, can be, it's just not there in some cases. And then then once you get to the recurring costs of recurring engineering costs, those obviously have to be low enough for the return on investment for human labor replacement, I guess, perhaps in
Yeah.
this case. And it's just it's a tough it's a very tough market even though it's a great market for robotics. It seems it's a great application. It's tough economically all around, because I've heard of similar things in other agricultural worlds and spaces. But
Yeah. And it's kind of my fault again, because I didn't pay enough. This time I did not pay enough attention to the cost. We kept going back to our customers and saying, every time we would increase the cost, we'd go back and say, oh yeah, that's still a good price for us. But it's not when they finally figured out how they were going to use it, it was not a good price. And I should have built in that safety margin of saying, no, the robot can't cost more than 50,000. It can't be six. It can't be. It ended up being $30,000, and it should have been closer to $6,000 or something, 7,500.
and that can be hard to achieve. But now, and this is an outdoor product, right? Or was it just,
Yeah.
yeah, okay. So it
Yeah,
wasn't
and
like
they turned the
limited,
sprinklers on too. So
right? So that's a
yeah,
rough on mechanical things.
yeah.
Did
Well,
you
we
get to that?
managed.
Yeah, you manage that process well, like to keep,
Yes,
okay.
yes. It would operate in mud. It would operate on uneven terrain. Uh, Honestly, it did really well inside a greenhouse where the floors are nice and flat. It could operate for hours and hours without attention. Outside, things would happen, and every once in a while, somebody would have to come by and restart the robot. But it was good enough even then. The thing that wasn't good enough was the price.
Right, right. Interesting. Your stories are more interesting, but I would say in the earliest of days, we had a group that wanted to have an apple harvesting. They had these apple, or no, nut harvesters, or whatever you might call them, where they, like, this big thing comes out from the side of this tractor, and it sort of hugs the tree, and then it shakes the tree,
Yeah,
and then the nuts or whatever it is falls
yeah.
into this bin, and we had it sort of auto steering along the copes of trees. And
Mhm.
but like thought, well, that was really easy. It's a lidar, some auto steering. You can retrofit existing vehicles, but like the just the we weren't venture backed for that, and the customers weren't, like, willing to pay for the research.
Yeah,
This is 2007 ish, so
yeah.
might be different today. Um, wow. So and then and so is harvest automation? I thought I saw that you were still an advisor or something in some capacity. Is it
Yeah,
still going, or?
it's it. There was a reorganization. The VCs who backed us lost their money, but it's still in business, and we do have 30 or 50 customers across the United States and in a couple of foreign countries as well.
Well, it seems like with robotics, it's grit, and staying power matter to be able to survive, because it just takes a long time to kind of figure out some of
Yeah,
these intricacies of problems, ranging from the domain to manufacturing, the economics. It's so much more than just, I'm going to write some software and put
yeah.
it on a piece of hardware, and I'll make it work. So
It would
many
be so great
factors.
if you got a second chance at it, because I could do it right now, and now I know how to do it. But
Well,
you
and I
sort of
do
get one chance.
I do wonder how some of the generative AI tools, and I don't know if you have any thoughts on that, but like can maybe help with simulations and just because you're training things on just massive amounts of data, and if that can sort of accelerate the intelligence that you can build into these products, and also just supporting some of the functions like getting customer feedback and distilling that into meaningful changes and change orders, or new revs and things like that that we didn't have 5 years ago.
Yeah. It's just speculation on my part because I don't really understand it well enough to say yes or no on those things. Um, I mean, we managed well enough without it. Maybe if we'd been more efficient about it, it would have taken less time to get to the place where we finally got to. Anything that would have given us a second bite at the apple would have changed the outcome dramatically, I think.
Right, right, right. Well, and then Turtle was also kind of in the sort of gardening space, or sort of
Yes.
adjacent to what you're doing. Tell me about that. I mean, that was more home and consumer oriented. Is that right?
Right, right. So I worked at Harvest for about 8 years or so, and when it didn't take off, um, the company looked for another thing that they could do, and they tried to get into warehouse robots. So that interested me less because in a warehouse robot, uh, the robot isn't the star of the show anymore. It's this gigantic piece of software called the warehouse management system that controls all the robots. It tells them all where to go and when to go there and stuff like. So I was kind of looking for another thing to do, and in that time frame, I went to this robot conference called Robo Madness in Cambridge one year, and I ran into an acquaintance there, and he was working on a little robot that would weed home gardens. So I was instantly fascinated because I had tried to figure out how to weed farm gardens. I mean, yeah, well, farm fields with a robot, and I hadn't been able to come up with anything that was any better than what people were already working on. Uh, so I didn't pursue that. But when you change the venue, it actually changes the difficulty of the problem significantly. And I thought, well, maybe I can do something in a garden that I couldn't do in a farm field. So I started working on that with him for a while. We made a bit of progress. I attracted another friend of mine who I'd worked with at iRobot in the very early days. And then the guy who had the idea, he decided to move on and do something different. But I thought it was great, so we kept working on it and attracted yet another friend of mine to be our CEO, since I hate all the CEO stuff. I'm not qualified to do that, so I had to find somebody else to help. So we started working on that, and we came up with something that worked really well. It's just this little um, it's this little robot
Oh
that
yeah.
that has a big solar cell on the top. So it sits in the garden until it has enough power, and then when it has enough power, it starts patrolling the garden. And it has it has a little weed whacker on the bottom. So
Oh
when it
yeah.
runs across a weed, it chops it down. But it turned out that the in some sense the weed whacker wasn't necessary, because just the fact that the robot was out in the garden all the time, sort of churning up the soil a little bit with with its ribbed wheels,
Mm-hmm.
um, tended to keep any weed seeds from growing.
Oh,
So
about that.
it worked great. I put it in I had one garden before we had the robot, and my garden was totally choked with weeds. And then I got the robot, and it had no weeds at all. So it was great, and we sold somewhere between 5,000 and 7,000 of them. But we ran afoul of the marketplace eventually, because even though we could build this robot for about $200, um, it was still too much. So we discontinued it after several years.
Wow. And now, was this a Kickstarter? I can't remember, campaign,
Yeah.
or okay. So that's interesting. And I guess so. I mean, not to go into too much details about that, but I guess like like how did that launch? Like, was it a good launch or
Yeah, we thought it was a pretty good launch. We really did our homework. You can't just have an idea and put it up on Kickstarter and expect anything to happen. We had
right,
studied the other people who had done this. We knew what we had to do, and a couple of the things that we had to do is we had to get people to write about us. We had to attract media attention, and we had to have as big a mailing list as possible. So we did those things, and we got pretty good traction. It was we were a bunch of different people wrote about us, and when we launched the campaign, we were hoping. Well, there's this thing that you have to do when you are doing a Kickstarter. You can't be too honest about your actual goal. Because if you say what we need is $200,000, which is what we thought, if you say that and you don't get it like immediately, then it looks like your campaign is sluggish and nobody is really interested in it. So you have to have a low ball. We learned this from another company that had done a Kickstarter campaign. You have to say, well, our goal is not it's not 200,000, it's 50,000. And then when that gets passed up in when you get the $50,000 early on, you can say, "Look how quickly we got our money, and isn't this a
right.
wonderful campaign? And don't you want to get on the bandwagon?" So we couldn't. We struggled with this, and I think eventually we ended up saying that our goal was $150,000, but it all worked because we got like 300 and some odd thousand initially, and then we kept it. Before we had started shipping, we kept it up for a little longer, and I think we got up to like $500,000 or something in total pledges. So
Gotcha.
that part worked fine. Um, and initially, the price was going to be $350, but we it turned and we had a number of customers who really loved it. I certainly loved it. I kept it in my garden. But it just didn't sell well enough, and we couldn't figure out any marketing scheme to get it in front of enough people to keep it going. We even managed to get on Ask This Old House. Um, a guy from Ross Trethewey from Ask This Old House came to my backyard, and we talked about robots, and it was on TV, and when something like that happens, you get a little spike
Yeah.
in sales, but you have to keep that going.
Yeah.
And of course, we didn't have enough money for a TV campaign, so we had to try other things, and ultimately, it wasn't enough.
Yeah. There's so many pieces that need to come together. And was that also contract manufactured overseas or?
Yes, it was.
Okay. So, I don't want to talk about this. I mean, unless you want to talk about it too much, because I want to kind of see what your sort of thoughts are on sort of the future here of robotics. But like with iRobot, I know there was the Amazon was going to buy it, and then there was some sort of um, EU or US sort of restriction that took place. Like they said, don't do it, and then they couldn't get the acquisition. I guess what's from your perspective? What happens to iRobot there? In this past year.
So, my perspective is that of a technologist, not a business person. So that will color what I say about it. I'm sorry that iRobot has ended up in this state. I really hope all the way along. I had hoped that they would pull through, but from the way that I look at it, they in some sense, they exploited themselves to death, right? They had one product, and that was really good product, and it lasted for about 20 years. And then they didn't have anything that came after that. Um, they did uh, devote a lot of money to developing something new, but somehow it didn't quite work out. I know that they worked on a robot lawnmower for at least 15 years, and they never pulled the trigger. They never did it. So uh, they never came up with another product that was revolutionary like Roomba. So the last thing that happened was that they tried to get bought by Amazon, and that fell through because of the EU regulations and all. But that wasn't the thing. As I look at it, that wasn't the thing that killed them. The thing that killed them was they didn't have anything after Roomba.
I see. I see. Yeah. Well, I mean, from, of course, outside perspective, an amazing company that has did the most amazing thing in robotics, home
Yeah,
consumer robotics in our lifetime, which is to sell, I don't know how many units were sold,
about
but
50
like
million.
50 million
Yeah,
robots is astounding. And giving like your insight into the trials and tribulations of of like manufacturing and all of those things, and to be able to do that is I mean, it's extraordinary.
it really is. It
It's an
really
amazing
is.
story. And your book, Dancing with Roomba, I assume you cover this and more.
Yeah, yeah. There's a whole bunch of really cool stories about that time. Um,
Well, I was going to try to read it before I talked to you, but I said, well, I want to talk to you first, and so that I don't have too much information. But I can't wait to read it. And so, like, now that I've talked to you, it's like it's on my list to read. So, it's that sounds like a fascinating book, and of course the insights into what it takes to build home consumer, you know, robots that are actually successful, like the Roomba was the most successful. I think I don't think there's any other example out there
yeah, nothing I
um,
know of.
that comes close to it. And of course, the amazing people, including yourself, that were behind it, um, is just an amazing story. I guess like if you had to, I know today, from your perspective, if you had to like, s- I've been thinking about like some of the new things coming along. Uh, and I'm wondering like what you might do differently today, given sort of like where technology has evolved and where things have come along. Like, would 3D printing change your perspective on how things should be manufactured? Is that there yet? Would that help or hurt some of the, because you can print carbon fiber, you can print many things, and or is that just not scalable yet to make robotics more economically manufacturable?
So I think I probably still would not rely on 3D printing for uh, for the manufacture of the part. But the fact that you can think of something, you can think of some design and just have it in a few minutes or a couple of hours, that's really amazing. We were able to use 3D printing uh, when we were developing Roomba, and it made a huge difference. It it cost a lot in those days. What you would do is you'd develop your CAD plan, you'd send it off to the 3D printing company, and they would send it back. And along with your files, you'd send like a check for $5,000, and then they would send back the parts in a day or two. And we couldn't have developed Roomba in nearly the time that we did if we hadn't had that. If we had the modern 3D printers, that sit on your desk, you don't have to send away for that. That would have helped us develop even faster, and the robot would have worked better from the get go. But I still think I don't know what I would use. Yeah, uh, I wouldn't rely on for manufacturing.
Yeah, not even. Yeah, I know, because I know there's like a group in Virginia that manufactures certain steel parts for ships using some obviously pretty beefy 3D printers of some ilk. And but and I don't know enough about it myself. But like, I've seen we use carbon fiber we print,
Mhm.
carbon fiber parts and what have you, smaller parts. And maybe for smaller robots, I thought, well, that could be something. But yeah, the machines and maintaining them and that whole micro factory concept, that like Local Motors, if you're familiar with the company that
Yeah.
they were trying to 3D print vehicular platforms, or at least parts of vehicular platforms, and they were doing an autonomous shuttle that was using these very large 3D printers to print like huge chunks of the vehicle. But yeah, it's um, but so what would you do differently today if you had to start again, on creating like a consumer or a home robot? Like what would you do differently?
Well, um, if I have vowed that if I ever did any other startup, I would begin with an industry expert on staff or as one of the founders. Um, that sort of is the biggest thing that I would do. I would certainly investigate how I could use the current crop of artificial intelligence tools uh, to uh, to develop more quickly and maybe as a part of the robot. Um, I don't have a detailed plan about how I would do this, but
Yeah, no,
if
just
something
some
cool comes
thoughts.
along, I'd be happy to develop one.
What do you think is like the most of the things we talked about? What's like the most misunderstood cost in robotics?
Most misunderstood cost.
I
Hmm.
and maybe I'm not. Is that? Yeah, I don't know if I'm clear about that, but like what's like the cost bottleneck, with producing robots today that people just don't expect?
Um, he, um, the thing that that lay people don't appreciate is how difficult robots are. They don't appreciate that if you see a robot demonstrate some ability, um, they think that because they understand how they do something, that the robot would have these other abilities, and that misleads people. As far as the cost, though, um, there's a huge cost in the testing because the real world is really complex, and you can't just imagine how it's going to work and then build your product around that imagining. You have to build something and then do a lot of testing in the real world to figure out whether or not it works. Um, the biggest thing that would help, uh, this is that it's a pipe dream, but the biggest thing that would help is when you get money from VCs to develop something, to have the ability to sort of do it a second time. Because when you build it the first time, robots are hard and you're going to miss critical things the first time you build one. If you can see the first iteration in the marketplace, how people actually use it, what actually breaks in practice, what doesn't work in which places, and then have another iteration so that you can address those things, that would lead to a lot more successful companies, I think.
Yeah, yeah, but I guess, and then there's the do you do it under the same brand or a different brand? I guess I've seen that in the past, right? Because it's like, well, because there's branding, right? And
Yeah, yeah,
if
right.
people don't like the first version, too much, then it's going to be hard to sell them the second version.
Yeah, the marketing issues like that are beyond the confines of my brain. I can think about technical issues. I can make those work, but the marketing,
Well, I've
customer
seen
expectations.
examples of some companies doing it under a second brand. There's been some history of that, right? Where it's like,
Yeah, yeah, I'm sure that makes sense.
um, what just some final reflective thoughts. What makes a robot iconic?
I wish I knew. That's like asking, how do you write a hit song?
Right.
No, I Roomba was a wonderful thing. It happened. It took a lot of luck. One of the biggest things that happened, among a bunch of big things, was that the team that worked on it was totally focused on that one thing. We were totally focused on wanting to build this robot that would clean the floor, and we weren't trying to show off to each other. We weren't trying to use as much technology as we could. In fact, we were trying to get rid of as much technology as we could, and we were of a single mind, and that made it, the most sort of the best professional experience that I've ever had working on the Roomba team. How do you catch lightning in a bottle the second time? I didn't get any dumber when I started my other two companies, but they didn't turn out as well. So
Yeah, it's hard. You see some of these a lot. There's a lot of venture capital that has been poured into some of these humanoid robotics companies, and they just look like very complex machines. And yours, the Roomba story is sort of like you say, it's like figuring out what you can subtract, not add,
yeah,
to make it successful, because there's all these, even with that, there's all these little things, manufacturing and just design subtleties that can cause problems. And of course, the more complex of a system you have, that is an exponentially growing problem.
yeah, right.
So it makes you wonder, I guess, about the humanoid robotics prospects. Tesla thinks, or the what is it that what is their robot, the Optimus robot that
Yeah, that's one of them.
that 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 um that they think is going to sort of be a big deal. But yeah, it's a complex machine. What makes a robotics company quietly disappear?
Oh, so many things. First off, not being able to execute on the dream that they have. You start something up and you think that you know how to do it, and then you meet the real world and it turns out that you don't know how to do it. That's not the biggest thing, though, that kills robot companies. I think probably the biggest thing is you don't truly understand the market, and you can't truly understand it until you have put the thing that you're trying to build in front of actual people and say, now, will you buy this?
Yeah.
Then you find out.
Yeah. Yeah. I guess last one, what and maybe it's a combo question. What robot do you want to have? Do you want to see in your home, today or tomorrow? And what are your hopes to kind of see in the next few years come out of the robotics world?
So I think it's something of a subtle answer, because I actually don't want a robot in my home. What I don't want a humanoid trundling around my home. What I want are things done for me. Like, I want to be able to throw my clothes on the floor and in the evening, and the next time that I want some clothes, I open the drawer and there's clean clothes. Right? That is what I want. And to build a system that will make that happen, hopefully invisibly, that's the thing that I would like to get to. The robot is incidental, and I don't want the creepy thing crawling around,
Right.
trudging around my house. I just want these things to happen, and they're invisible to me. I don't have to do any work. It's just there when I want it.
Interesting. And is that applied to the second sort of part of that question, as to what robots you would like to see? Or
Yeah, yeah. I'd like to see a one that would deal with my clothes. I would like to see one that takes the trash out, so I don't have to do that. And
like to see it such that it's not seeable, invisible, so
yeah,
it's
right.
transparent. Yeah. Makes sense. Makes sense. Well, Joe, thank you so much. I'm really looking forward to reading again your latest book. I guess it was produced in just a few months ago, October or
Yeah,
something, right?
came
And
out end of October.
on Amazon. I'm a Kindle guy, so I'm gonna I've Kindled it. And
Cool.
like I said, mobile robots was such a foundational book for it sits on my shelf today, and then all the things that you've done with Roomba, making one of really the most commercially successful robots on the market is just amazing. And I'm just honored and appreciative that you took the time today to talk to me. I think so many people will enjoy these stories and similar ones that you have in your book. So thank you so much.
Well, thank you. I have to say that Roomba amazed me too. I never thought this cool little project that we worked on would come to so much.
I have 4 cats, and all those cat videos of the cats riding on the Roombas. It's a true thing. Cats are just drawn to these things.
We did not expect that.
Well, thank you, Joe. I appreciate it so much.
Oh, thank you, Paul. This has been great. I really enjoyed speaking with you today. Thank you so much.
Likewise.